Alright, good morning calc class. I never know what to say at the beginning of these videos. It's always kind of awkward talking to myself at the beginning until I start talking about math and I get on a roll. But I didn't give you notes yesterday, just gave you those problems because I figured you could handle it. Let me know if that's not true. Right now I just want to review solving, as you can see, solving absolute value and quadratic inequalities, and then we'll do some exponential stuff. And if you notice any breaks in the video, it's because I'm stopping it and then splicing a whole bunch of different ones together, so I don't have to do it all in one take. So when I mess up or something, I can edit it. Just kidding. Hope I'm talking loud enough. I'm tired and I have a headache, so I don't really feel like doing this right now, but here we go. So solving inequalities, you'll have a few of these to do. This is actually in 1.2, the quick review problems. I'll show you how to do like number 2. Let's see, it's x times x minus 2 is greater than 0. Well, the whole concept of inequalities is a lot easier if you picture it graphically, so before I even explain how to do that, if you just think of a simple one like either the absolute value of x or x squared, and we can do greater than or equal to, let's say 4 is easy. Either one, it's kind of the same thing. If you think about it graphically, do the absolute value one. Absolute value of x, if you look at the graph, that's just a v, right? Well, this is asking when is the absolute value of x greater than or equal to 4. So you think about it, 1, 2, 3, 4, there's 4. So it's saying when is this function bigger than 4? Well, out here in this region it's a bit bigger than 4, and then here's 4, and then over here it's bigger than 4. And so basically you're trying to find the x values. What is this? If you can figure out what that is, then you can say, oh, when x is greater than question mark, this absolute value graph is greater than 4. And also when x is less than the question mark. Well, in this one it's easy because it's just 4, right? Because the absolute value of 4 is equal to 4. The absolute value of negative 4 is equal to 4. So your answer would be when x is greater than 4 or when x is less than, oops, still should be equal to, we're doing less than or equal to. That could be your answer. The way I got 4, well, let's look at the parabola one. I don't know how well I'm explaining this. X squared is greater than or equal to 4. If you think about that, this one's same thing, just a parabola now. When will that parabola get above 4? Well, that's why I always said just solve it like an equation first. Because if you solve it like an equation, x squared equals 4, that'll tell you exactly where it is equal to 4. When is this parabola equal to 4 on the y-axis? That'll tell you those points, which are good to know because it's going to be greater than 4 either, if you think about the x-axis, it's going to be greater than 4 either outside or inside of those. And that's where we had those test regions come in, remember those? So like when you do this, square root of both sides, square root of 4, boom, you get plus or minus 2. Well, yeah, those are 2 and negative 2. Now on the graph it's easy to look and say, oh, when x is greater than or equal to 2, my parabola is bigger than or equal to 4, or when x is less than or equal to negative 2, my parabola is greater than or equal to 4. But if you don't have a graph, and you just get that as your answer, that's where we set up. We go, I know there's a whole region over here where something's happening, so we'd go from negative 2, from negative infinity to negative 2. And then I know in this middle region something's happening, so I would set up negative 2 to 2. And then I know over here something's happening. Even if I don't have a graph, I can think about a number line. And go, okay, from 2 to infinity, something's happening. And then remember, we picked numbers in this region to test in the original inequality to see if it worked. So like here, I can pick negative 3. Negative 3 is over here somewhere. If I pick negative 3, plug it in, negative 3 squared is 9. 9 is greater than or equal to 4. It works. So that's part of my solution between when x is between -2 and -infinity. That's this right here. That's where I got that answer if I don't do it graphically. If I pick a number in here like 0, plug it in, 0 is greater than or equal to 4, it doesn't work. If I pick a number like 3, hey, same thing, it works. Whoops, 3 squared is 9. So that was just like quick. So let's put it to action. Put it into action in one of these problems. So like here, at first glance, you may not know what the graph of that looks like. So, like I said, just solve it like an equation first, and that gives you those critical points, or the points where this will be equal to 0. Then you could set up you'll have some separate regions, and you'll know that it's either above or below 0 in those regions, because it's not going to stay equal to 0 the whole time. So to solve that, well, I know a lot of you would try distributive property probably, and you'd go x squared minus 2x, but then you just took a step backwards. That's already a factored form of a quadratic. So if we're solving it like an equation, you just set both of them equal to 0. It's already factored. So x equals 0 and x minus 2 equals 0. Add 2. Boom, we got x equals 2 and x equals 0. Those are our critical points. This function is either going to be above or below 0. To, think about a number line. Here's 0, here's 2. Over here, it's going to be above or below 0. I don't know. When x is 0, it's going to be equal to 0. And when x is 2, it's also going to be equal to 0. So in here, it's going to be above or below, and over here, it's going to be above or below. So now I'm just checking to see what's happening. If you think about it, if you know about graphs, you can just think about it and get the answer, because you know that's a parabola that opens up because it's positive, and you can probably fill in the blanks, But if you can't, let's do the test region thing. So -infinity to 0, between 0 and 2, and 2 to infinity. Pick a number in each one, so I'll pick, let's see, I'll pick -1 in there, 1 there, and 3 there, and plug them back in. And we got, let's see, -1 plugged in up here. Let's see, that'd be -1 times -1 minus 2. So it could be -3 times negative. That's 3. Is 3 greater than 0? Yes. So that's over here. My function will be greater than 0, which drawing in my parabola, that makes sense. In the middle, let's see, 1 times 1 minus 2, that's 1 times -1 is -1, that is not greater than 0. And then I get 3 times 3 minus 2, that's equal to 3, that's greater than 0. So over here I'll be greater than 0, so that's x is less than 0, and over above there x is greater than 2. Remember, I'm just doing less than and greater than because I have to be greater than 0, not where it's equal. I can't include 2 in my answer because that's where the function is equal to 0. So there's my answer. Absolute value, same thing. So like number 4. The absolute value of x minus 2 is greater than or equal to 5. Got to solve it like an equation first. So absolute value of x minus 2 is equal to 5. Well, you got to remember how to solve an absolute value equation. I hope I'm not shaking the camera too much. I just noticed that. Sorry, it's difficult. Oops. Remember absolute value. Whatever's inside here, I change it to positive. So if I got a 5 inside my absolute value bars, that'll make this equation true. So I know stuff inside x minus 2, if that's equal to 5, this will be true. Or the stuff inside of here, remember, block it out. If there's a -5 in there, that -5 will turn positive because of the absolute value, and I'll have it true. So the stuff inside could be equal to -5. Or basically just stuff inside, set it equal to positive or negative that side, solve it, add 2, x equals 7, add 2, x equals -3, Boom, there we go. Think about a number line. Here's -3, here's 7. So I have this region, and this region that I need to test. You could take it from there if you needed to. This video is already way too long for this. So that's how you'll do those first few problems. Okay, next we'll talk about properties of exponents and then exponential functions. But properties of exponents, simple stuff like if you're multiplying like bases, add the exponents. Remember all this. If you do a power to a power, you multiply them. It's x to the 6, right? If you divide, it's like subtraction. I just think if there's 3 on top, 2 on bottom, I'll have 1 left on top. It's almost like subtraction, but if you have like x to the 10th over x to the 50th, you could write x to the -40th, but remember negative exponents, we don't like them, so you take that, drop it, so you get 1 over x to the 40th, stuff like that. If you have x over y to the 3rd, that's the same as x to the 3rd, y to the 3rd. All these rules, it's on page 23. There's like a yellowish, brownish, tannish box. It says rules for exponents. It's all there. It's an easy deal. Alright, but I think you guys remember those problems like, I don't know, I'll just make one up, like x to the -3rd, y to the 4th squared over, I don't know, x squared, y to the -3rd to the -3rd. Stuff like that. So it's like, it's like a combination of order of operations and rules for exponents. So you gotta do your parentheses. Power to a power, remember you multiply, so I'll take x to the -6, this will be y to the 8th over 2 times -3 is -6, and -3 times -3 is y to the 9th. Well, that one turned out easy. I know a lot of you would go, oh, I have negative exponents, so I'll move this one down and I'll move this one up. Well, okay, cool, but if you have the same thing on top and bottom, just, yeah, it's going to be 1. Y to the 8th over y to the 9th, you get 1 over y. Stuff like that. That turned out easy. You got a couple of those you got to try. But I want to talk mostly about functions. So like y equals, remember exponential functions, y equals ab to the x, or just y equals, I think in the book they just write it y equals a to the x. They're not putting the number in front. Doesn't matter. The number to the x power, that's always like the multiplier, right? Remember that? Then you got like your initial value, or your, I was going to say y-intercept, but that's not completely true. So y equals a to the x, just talk about the basics. Like if you had y equals 3 times 2 to the x, what does that mean? Well, let's look at a table. If you have x is 0, that's going to be 1, so y will be 3. And then as x increases by 1 each time, you're just, this is like 3 times 2 to the 0, this will be 3 times 2 to the first, 3 times 2 squared. You're just multiplying by 2 an extra time. So this is multiplying 3 times 2, so you're going to have 6. And 3 times 2 times 2, because it's 2 squared, so that's going to be 12. Right? So in a table, it just looks like the y values are getting multiplied by 2. That's why we called that the multiplier. On a graph, you'll just have, oh, x is 0, y is 3, so you're going to start at 3. And remember, if this is above 1, if it's a number, if the multiplier is over 1, you're going to have exponential growth. It's going to get bigger and bigger and bigger, so it's going to look something like that. We're not going to get exact. And I keep covering the camera, sorry. If your multiplier is like half, so let's say you had y equals 4 times the half to the x. Well, think about a table. I don't want to, but you're going to start at 4. Multiply by half as x gets bigger, so 4 times a half is 2. It's going to get smaller and smaller and smaller. And if you go backwards, 4 to the negative half, or not to the negative half, 4 times 1/2 to the -1. Well, -1 power, you put it over 1, you're going to end up flipping it. It's multiplication. If you want to know why it works, I guess you can ask me when I Skype you. It's a pretty exciting conversation. But yeah, it's going to go down if your multiplier is less than 1. And we can also shift these things. Like if we have this same 1 and we add or subtract 4 off the end, it's just like with any other function. If you subtract 4 at the end, it's going to shift it down 4. So now your new y-intercept will be 1, and it'll be the exact same thing, just shifted down 4. Or we could add 4 and move it up 4. Alright, you just got to be able to identify these on these problems right here in your book. You're just going to have to do matching without your graphing calculator. On 1 through 4, you are going to have to do some graphing, but you can use your graphing calculator. I'll show you number 3. Actually, no. I'll show you let's go number 10, just because it'll kill 2 birds with 1 stone here. So number 10 in section 1.3, it says find the zeros use a graph to find the zeros. So we got f of x equals e to the x minus 4. Number zeros are like x-intercepts. Not are like, they are the x-intercepts. So if we have e to the x minus 4, I'll tell you right now, e is a number. It's a special number. We'll talk about it more when we get to limits, the actual calculus stuff. But it's equal to, it's about, I think, 2.71-ish, something like that. I don't know, 2 point something. So anyway, this is just going to be like 2 to the x power. Well, it's just going to be a exponential growth and down 4. So I know my graph should look something like that. But let's do it on the calculator. So remember y equals, clear out the stuff I got in there. So I gotta go e to the x. E is right there above the ln. You gotta push second ln. So I got e to the x. I have to close the parentheses because that's just the power. So it's e to the x power. And then subtract 4. I'm gonna graph it in my standard window. Hey, look at that. That was pretty accurate. Now to find the zeros, the x-intercepts. I don't know that I've ever showed you this. Above trace, there's a button that says calc right there. So you push second, calc. It's going to calculate. Well, option 2 says 0. That's nice. So it's going to find our zeros for us. So go to 2 and hit enter, or just hit 2, whatever. But now it comes up with a question that says left bound. And you'll see like a flashing little cursor there, and I can move that cursor left and right by pushing the left and right arrows. Well, left bound, it wants you to kind of narrow it down for it so it doesn't have to search so long. So you're going to put that cursor to the left of the x-intercept, anywhere to the left of it. I could put it anywhere along here. It does not matter. You just put it over there somewhere, hit enter. Now it'll say right bound. Well, now you want to go to the right of the x-intercept somewhere. So I move that cursor to the right of it, and I hit enter again. Guess, put it as close as possible. It just helps the calculator go faster. Hit enter again. Oops, I hit negative. I didn't hit enter. Let's delete that. My guess. Okay, I'll just type in a guess. 1.5. I think it works like that. Hit enter. Yep. And now it'll tell me my 0 is x equals, I don't know if you can read that on the camera, 1.39, 1.386. So my 0 would be 1.39. So finding zeros in the calculator is pretty simple. Graph it, do calc, 0, go to the left of it, hit enter, go to the right of it, hit enter, go close to it, hit enter again, and it'll tell you. If there's more than 1 0, you just got to do it that process more than one time. Okay, so there's that. Thought of one more thing that I forgot when I was picking the homework problems. It's not about exponential functions, it's more of just the properties of exponents thing. It's in 5 through 8. It says rewrite the exponential expression to have the indicated base. So they'll give you like 16 to the power of I don't know, 2x. And it'll say write it with a base of 4. Well, all that's saying, this is the base number, this is the exponent. If if I want to rewrite that with a base of 4, I just have to change it to, well, isn't 16, if I want to change it to a 4, isn't the same as 4 squared? So all I did was I changed the 16 to 4 squared. It's still to the 2x power. Well, so now I have 4 squared to the 2x. Well, if I have a power to a power, I just multiply them. So I got 4 to the 4x. So 16 to the 2x is the same as 4 to the 4x. Or they'll have some fraction ones that'll say like, let's see, I'll do like a crazy one. Like if you had 1/64 to the 2x power, and rewrite that with a base of, let's go 4. So you have to change that to have a base of 4. Well, that's no problem. 4 to what power gives me 1/64? Well, 4 to the third gives me 64, so if I want 1/64, I'm going to flip it, so it's 4 to the negative third power. 4 to the negative third is the same as 1/64. That's to the 2x power. Boom, just multiply those. You got 4 to the negative 6x power. And that's very loud. So I'm glad I'm done. I think they're painting my wife's sister's apartment building. They're scraping. Oops, where'd the homework go? I wrote down the homework somewhere and I lost it. Oh, there it is. So there it is. Pause it if you need to. I'm shutting it off.